Hi, my name is Amelie, and I'm a final year master's student at the University of Antwerp in Belgium. Together with a research group endemic, and as part of my thesis research, I studied the role of trees in mitigating the urban heat island effect in street canyons. Why study trees in the built environment? Well, the urban heat island is a direct consequence of urbanization and industrialization and presents one of the pressing challenges of the 21st century. It can be primarily attributed to the extensive amount of incoming solar radiation that is absorbed and re-radiated as heat by urban infrastructure. This puts society under increased heat stress and will only get worse with ongoing global climate change. Trees have the ability to cool their immediate surroundings through the important process of evapotranspiration, and by bringing them back into the built environment, they can help us make cities more livable and future-proof. So then my question is, to what extent can trees act as our natural air conditioners on a street level? The idea is simple. Street canyons with trees will be cooler than street canyons without trees. And so if we want to observe the extent of the urban heat island mitigation by trees, we can compare temperature gradients of streets with trees to streets without trees. And with that in mind, I set up 37 sensors that measure hourly temperatures in 3 adjacent streets in the city of Antwerp. These typical residential street canyons were chosen based on their proximity, similar orientation, and of course their difference in number of planted trees. Looking at the map, the dark blue indicates a street with a row of mature trees, the light blue indicates a street with a few young trees scattered throughout, and the street in the middle has no trees at all. The experiment started last year in April and will end exactly 1 month from now. Because my thesis project took place in a densely inhabited urban environment, the help of local citizens was essential to its success. 20 local citizens joined in on the research and attached the sensor within a small V-shaped billboard on their windows facing the street side. By the end of next month, I will have collected just under 325,000 data points. So analysis is still on its way, but I do have some preliminary results to share with you today. 2020 markedly was the hottest year since records began. The nationwide heat wave event in August showed some record temperatures, reaching 43 degrees Celsius on the 8th of August. Zooming in on this day, the graph shows temperature gradients that follow a similar course around sunrise, sunset, and at night, but they diverge during hours of peak incoming solar radiation. The graph also shows the importance of street canyon geometry and orientation, as there is a clear difference between temperatures measured at the east and west side of the street with trees. The importance of shade provisioning should not be underestimated either. The peak in the dark blue gradient appears when the sensor was exposed to direct sunlight, but as soon as the sun starts to drop and the sensor is covered by shade from the tree once more, there is a sharp decrease of around 7 degrees Celsius. If you compare this to the street with no trees, you see that it maintains these high temperatures for longer. It would be premature for me to conclude that trees indeed have such an extensive cooling effect, but the results definitely seem very promising. Thank you all for having me, and if you have any questions, please let me know, and I will try to answer them as best as I can.